Today we're going to do Chapter 11, Section 7, Graphing Rational Functions. There are 4 parts to today, and they all relate to each other. The first thing we're going to do today are excluded values. And we've talked about those at the beginning of Chapter 7 before. The other thing we're going to do is asymptotes. Asymptotes are almost the same as excluded values. We're going to graph these, and in order to graph them, we're going to use the excluded values or the asymptotes. It's kind of nice once you find one thing, you're going to use it for the rest. And then we're going to decide what it looks like on a graph. I think we're going to write equation there, deciding what an equation. I made this a while ago, I guess. It looks like on a graph. Part 1. You've already done this, so it's just excluded values. We did this back in Chapter 11. We have to set the denominator equal to 0. And then solve for x, or whatever's in your denominator. So when we approach problem 1a, we need the excluded value. I see the denominator is 5 minus x. I know denominators are not allowed to be 0. So in order to do this, I take away 5 from both sides. I get negative x equals negative 5. I divide by negative 1. And x, it's not allowed to be, cannot be positive 5. So that is problem A's excluded value. Do the same for problem B. X minus 4 is not allowed to be 0. Add 4. X is not allowed to be 4. And there's nothing in front of x, so there's nothing to divide by. So that's my excluded value. Problem C. Take the denominator, x. It cannot equal 0. So we have x is not allowed to be 0. And there's no solving. That's it. That's the end of the story. So that's how you find excluded values. Okay, now part 2. How do you find asymptotes? An asymptote is a line on a graph that a graph approaches, but it never touches. If you tried to get a value there, your calculator would say error. So if we look at these examples here, these are what we just did. If you remember on problem A, we got the excluded value of 5. That's because when I graphed it, you see how like at 5, there's this like vertical line that it touches, but like these things never ever touch. Okay, that's why it's an excluded value, because that 5, when it moves over to the right 5. This one happened at 4, 1, 2, 3, 4. This one happened at 0. So you can see it's a line that a graph approaches, but the graph itself never touches it. Okay. Rational expressions have 2 asymptotes. They have a vertical one. That's what x can't be. And they have a horizontal one. That's what y can't be. I hope I can make sense of this pretty easily for you. So it's really just like as long as x is first, it's opposite of what's with x. Oh, I'm sorry, there's a cat in my way. Kitty cat. Okay. You guys are enjoying this, aren't you? Okay. So you see how we have x plus 1 here? That means the excluded value, the vertical asymptote, I'm going to draw a line over here. The vertical asymptote is x equals negative 1. It's opposite of the bottom. And it is actually the excluded value as well. Now you see the number in the back? That's what y is not allowed to be. That's the horizontal asymptote. So we would say the horizontal asymptote is y equals 5. And it's a horizontal line at y equals 5. So I'd like to practice using these examples down here. Let's zoom in though, because they're really tiny, aren't they? Okay. True or false? The vertical asymptote is x equals 2. Unfortunately, that's incorrect because it's opposite of this. So this one's false, and if we wanted to make it true, we would cross off the 2 and we would say x equals 5. The horizontal asymptote is the number in the back, and it's y equals. That matches. Y cannot be a positive, or y, the asymptote is y equals 4 because y can't ever be positive 4. That is a true statement. Now we'll move on to problem 2, finding the asymptotes of a graph of a certain function and graphing it. Excuse me. So I'm going to circle this plus 1 in the denominator and the fact that there's nothing in the back. So what that means is that I have a vertical asymptote and a horizontal asymptote. The vertical asymptote is x equals. The horizontal asymptote is y equals. X cannot equal the opposite of this, negative 1. That is because if you have a negative 1 down here, it would make your denominator 0. And because x cannot equal a negative 1, this number in the back, this big fat 0, y would be the asymptote of 0. Now I'm going to get a marker so I can color. And this might be easier for you to see it visually, making it ourselves. So here's where x is negative 1. So you see this line I'm drawing? It will never touch that line, and it will never touch, turn my paper to the side, this 0 line, this y equals 0 line. So those are the asymptotes. I'll underline them in orange so they color code. In order to graph it, we just have to pick some x's and plug them in. But we start with this number, this x equals negative 1. We start with that number in the middle. Okay? And that's going to be our asymptote because that's going to be the undefined part. All right, let me get my calculator. And let's surround negative 1 with points. So I'm thinking we could even do, instead of going straight to 0, we can do negative 0.5 and then 0 and then 1 and 2. And then we can go the other way as well. We can do negative 1.5, negative 2, and negative 3. Do I have an even amount? 1, 2, 3, 4, 1, 2, and negative 4. I think I wrote my x's backwards, but it doesn't matter as long as I'm careful when I plug them in. Okay, please watch carefully as I plug this in, okay? So I'm going to do 3 divided by parenthesis. I'm going to plug in 2. 2 plus 1. So that gives me 1. And you can always plug more points in if you're not sure what your graph's going to look like. Now we'll plug in 1. 3 divided by parenthesis. 1 plus 1. Whoopsie. And I get 1.5. Now let's plug in 0. 3 divided by parenthesis. 0 plus 1. And I get a positive 3. Now let's plug in negative 0.5. And I get positive 6. So I plugged everything in for that x right there. Now let's plug in, I'm trying to decide where to put this, negative 1.5. And I get negative 6. Now let's plug in negative 2. and I get negative 3. Let's plug in negative 3. And I get negative 1.5. And let's plug in negative 4. And I get negative 1. Last but not least, we're going to plot our points. Over 2, up 1. From the origin, okay, not from the asymptotes. Over 1, up 1.5. Again, from the origin, not from the asymptotes. Over 0, up 3. Over negative 0.5, up 6. So we can see this graph is quickly growing. Just like we studied in 11.6, we know the shape kind of curves and it approaches that, but it will never touch that. This one was really messy. It's going to approach it, but never touch it. Okay. Now do the opposite side. So negative 1.5, negative 6. If you need to pause me because I'm going fast, please do that. Remember, we need to be going from the origin. I just screwed that up. Not the asymptotes. And there we go. Remember to go from the origin, not from the asymptotes. Oops. There you go. And that's the really pretty graph. All right, I know that took a long time. I'm not going to give you a ton on your homework, I promise. Number 2, we're going to do this how many more times? You know what? I have 4 of these. How about we don't do number 2? The only difference on number 2 is you see we have a negative 3 on top. That they would be here and here. The graphs would be here and here. Okay. Let's skip to number 3. I think if I give you 2 examples, that's enough. If not, go ahead and do another one, and then you can ask the teacher how you did with it. Okay. So I'm going to say that I have just like I did in the last one, a vertical asymptote and a horizontal asymptote. The vertical asymptote is x equals, the horizontal asymptote is y equals. And the x one is opposite of the denominator, so negative 3. Just like our excluded value would be. And our our horizontal one is what's in the back, a minus 4. Okay, I'm going to graph those so I can see where my graph is moving. So negative 3 is over to the left 3. 1, 2, 3. So it's not going to touch that orange line. Really, I should probably be drawing these dotted, but as long as you get the idea that they're approaching them. And the negative 4 is, I gotta turn the paper, it's gonna go down 4. And it's not gonna touch this line, okay? So it's kind of interesting, we may as well note that if we have a plus 3 right here, that's moving it left 3. And if we have a minus 4 in the back, that's moving it down 4. Now it's time for our XY chart. And this is good because we'll practice another with a negative on top. That's probably a good thing to practice because our last one had a positive on top. Okay, so we are going to start our middle x value with negative 3, but if we were to plug in negative 3, it would be undefined. Okay, let me get my calculator ready again. And I feel like I need to say this too. You guys should be fully capable of doing this without a calculator. Obviously having one just makes it really nice, but you should be able to plug numbers in without. All right, so negative 3, I'm going to go to negative, just a little bit, like negative 3.5, and then negative 4, negative 5, negative 6. That should give me a pretty good graph. And then a little higher, negative 2.5, negative 2, negative 3, negative 4. It might be a good idea for us to get used to doing like a decimal one there, just so we can get a nice, pretty graph and know what it really looks like. All right, time to plug things in. So we're going to start with a negative 1, divide by parentheses. I'm going to plug in negative 6. Negative 6 plus 3, and then close your parentheses, minus 4. That's negative 3.7 when we round. Okay, let's plug in negative 5. When I plug in negative 5, that gives me negative 3.5. Not a huge difference there. When I plug in negative 4, get negative 3. When I plug in negative 3.5, I get negative 2. And then I already knew this was undefined. Let's plug in negative 2.5. That gives me negative 6. Let's plug in negative 2. Get negative 5. Let's plug in negative 3. Oop, that's right, I shouldn't have to plug in negative 3. That's because I chose really bad x's here. I should have picked negative 1 and 0 if I would have been counting right. But isn't it interesting? Like I said, when I plugged in negative 3, I got undefined. So that was good that I saw a mistake there. I'll plug in negative 1 instead, like I should be. Silly me, I didn't count. Or negative 2, I was not counting well, was I? So negative 2, I got negative 5. Oh my, okay. Now negative 1. Negative 4.5. And finally, why did I, not negative 0, just 0. It must be early in the morning. It is. And I get negative 4.3. Now, if you're watching this and you're like, boy, she's really good at plugging in numbers, you should probably try it yourself and make sure that you can get these values, because if you can't do it now, you guys aren't going to be able to do it on the test or the quiz it's going to be. So please make sure that you're trying to plug those numbers in as well and that you can get these y values out. Otherwise, I mean, I can do it all day for you, but if you can't do it, that's not going to be helpful. All right, from the origin, go left 6 and down 3.7. All right, there it is right there. Now go left 5 and down 3.5. Left 4 and down 3. You might need to pause. If you guys are showing this to the whole class, my substitute might want to pause this to make sure kids are keeping up, because I'm plotting points pretty fast here for them. All right, so there's one side. I see the curve, so I'm going to be able to draw a nice graph here. Take the curve, approach this line, but never touch the line. And same thing down here, approach the line, but never touch the line. And then do the same thing over here. Negative 2.5, negative 6. You can see that it's going to be reflected on the other side. Negative 2, negative 5. Negative 1, negative 4.5, negative 4.3, and you can see the curve happening here. Again, if my substitute can monitor my students to make sure they're keeping up with the video, especially they don't have this video on fast speed, because I'm pretty quick at what I do, so they shouldn't be they should be waiting and they should be doing it themselves. Okay, let's move on.